In this video, we'll make a browser application that lets you draw pictures on the SenseHAT board for Raspberry Pi. First, install the SenseHAT package on your Raspberry Pi. Then, install the SenseHAT DSLink. And start the link. It might take a few minutes to start. The SenseHAT DSLink lets you get the value of SenseHAT metrics and do actions on the LED matrix, such as turning on given LEDs with the given colors, displaying a scrolling message, like the one you see here, setting a pixel to the given color, and turning off all of the pixels by clearing the screen. To create a pixel setter app in DGLux5, first draw a square. Convert the square to a symbol. You can delete the instance of the symbol after you've converted it, then insert a group. Set the symbol to repeat inside the group, and create a table that will make the symbol repeat 64 times. Since repeaters create a symbol instance for every row in the table, this means the table needs 64 rows. Link the table to the group. Give the group horizontal layout and turn on wrapping. Expand the group to an 8x8 square. Now, insert a color input component. Double-click the blue dot next to value so that you can work with that property, and double-click a symbol instance to start editing the symbol. Open the square's data flow. Insert a color block, and bind the input component's value to it. Insert a script block, and give it a string property named color. Paste the provided script in the script block, and bind the color block to it. The script takes a color string in one format and changes it to a different format. Insert a number block that gets the square's index inside the group repeater. That means it gets whether this is the first, second, or 64th square in the grid. Right-click SenseHAT, click Set Pixel, and drag it to dataflow to add a Set Pixel action block. The Set Pixel action will be invoked by an onClick event. It will take the reformatted color string as its color, and some arithmetic on the square's index will yield its x and y coordinates. To see what you've done so far, double-click the stage to exit symbol editing mode. So far, you can use the UI to update the SenseHAT, but it doesn't affect the grid yet. Right-click the symbol in the Symbols panel to re-enter the symbol editing mode. Configure a set state action for the symbol using an event like onClick. Record a state change for the action that includes changing the fill property of the square. Then, in the state block, double-click the blue dot next to background to work with that property, and bind the color block's value to it. Click OK to exit symbol editing mode. Now you have a simple working app. You can change one pixel at a time on both your UI and your Raspberry Pi. Next, we'll create a Set All button that sets all of the LEDs to the selected color. Insert a text component. Open dataflow for the text component. Insert a color block that takes the color input component's value. Insert a string block and a script block. Give the script block a string property named color. Paste the provided string and script into these blocks. The script block takes the selected color as its input. It outputs an RGB string. Do a find and replace to insert the script output in all 64 pixels within the pixel array string. Set the script block to autoRun. This means that the script output will change whenever the input changes. Right-click SenseHAT, click Set Pixels, and drag it to the dataflow. Make sure that the Set Pixels block uses the pixel array string and is invoked by an onClick action. Double-click the blue dot next to onComplete so that you can work with that property. Create a set state action for the symbol. Bind the onComplete event to the Invoke trigger. Record some action that changes the symbol's fill property. Double-click the blue dot next to background. and bind the color block's value to it. Now you've created an action that changes all of the symbol instances to the selected color. Double-click the stage to exit symbol editing mode. Use the viewer to use and share your app. Now your application includes a working Set All button. Stay tuned for more tutorials on Raspberry Pi with DSA.